Imagine if something from another star system was racing toward our planet right now. On July 1, 2025, astronomers made a discovery that sent shockwaves through the scientific community, a mysterious object traveling at impossible speeds through our solar system. Meet 3I Atlas, the third confirmed visitor from interstellar space, and, honestly, it's unlike anything we've ever seen before. A rare visitor from deep space. What if I told you that right now, something ancient and mysterious is flying through our solar system at speeds that really defy imagination? This isn't science fiction, it's happening above our heads at this very moment. The object in question has been officially designated 3I Atlas, marking it as only the third confirmed interstellar visitor ever detected by human civilization. But, this cosmic wanderer is different from anything we've encountered before. Racing through space at an incredible 58 kilometers per second, it's moving faster than any previous interstellar object on record. What makes this discovery even more remarkable is that 3I Atlas was spotted while still incredibly far from Earth, giving scientists an unprecedented opportunity to study a visitor from beyond our solar system. Unlike typical asteroids or comets that orbit our sun, this mysterious traveler originated from somewhere else entirely, possibly from a star system so distant that its light hasn't even reached us yet. The implications of this discovery are staggering, raising questions about what lies in the vast emptiness between stars and whether we're truly alone in the cosmos. As telescopes around the world track its every movement, one question echoes through observatories everywhere. What secrets does this ancient wanderer carry from the depths of interstellar space? The breaking discovery. Why does finding 3I Atlas represent one of the most significant astronomical discoveries of the decade? The answer lies in just how incredibly rare these interstellar visitors actually are. Before 2017, scientists had theorized about objects traveling between star systems, but none had ever been confirmed. The discovery of the third interstellar object in less than 8 years suggests something profound about our galaxy. It's filled with wandering worlds ejected from distant solar systems. 3I Atlas joins an exclusive club that includes only one Oumuamua and two Borisov, making it one of just 3 confirmed visitors from beyond our solar neighborhood. What makes this discovery particularly exciting is the timing. Unlike previous interstellar objects that were discovered when already leaving our solar system, 3I Atlas was spotted early enough for extensive study. The scientific community erupted with excitement because these objects represent actual samples of other star systems, carrying pristine materials that formed billions of years ago around distant suns. Each interstellar visitor provides a unique window into the formation and evolution of planetary systems throughout our galaxy. The rarity cannot be overstated. Statistically, we might expect to see one interstellar object every few years, yet we've now discovered 3 in rapid succession, suggesting our detection capabilities have finally reached the threshold necessary to spot these cosmic messengers regularly. The discovery story. How does one spot a cosmic needle in the haystack of space? The incredible detection story of 3I Atlas began in late June 2025, when the Asteroid Terrestrial Impact Last Alert System was conducting its routine sky surveys. The Atlas telescope in Rio Hurtado, Chile first captured this mysterious visitor on July 1, 2025, initially cataloging it with the mundane designation A11PL3Z. At first glance, it appeared to be just another faint moving object among millions tracked by automated systems. However, within 24 hours, something extraordinary became apparent. Follow-up observations revealed a faint coma and tail, immediately transforming the object from a potential asteroid into a confirmed comet. But the real surprise came when astronomers calculated its trajectory and velocity. Moving at an unprecedented 58 kilometers per second relative to our Sun, 3I Atlas was clearly not gravitationally bound to our solar system. The Minor Planet Center quickly recognized the historic significance, officially designating it as 3I Atlas, the 3I prefix reserved exclusively for interstellar objects. Professional and amateur astronomers worldwide mobilized telescopes to capture this fleeting visitor, collecting 122 observations from 31 different observatories within days of discovery. The rapid identification and confirmation process showcased how modern astronomy has evolved to quickly recognize these rare cosmic visitors before they vanish back into the darkness of interstellar space forever. A stranger in our midst. So, what makes 3I Atlas so fundamentally different from everything else in our solar system? Well, the answer really lies in its absolutely mind-bending characteristics that, honestly, challenge our understanding of typical cosmic objects. First off, there's its incredible velocity. Racing through space at 58 kilometers per second, it's moving nearly twice as fast as the previous interstellar record holder, 2I Borisov. This extreme speed gives 3I Atlas a hyperbolic orbit with an eccentricity of 6.141, which means its path through our solar system appears almost perfectly straight rather than curved. The object's brightness has been measured at approximately magnitude 18, making it visible only through powerful telescopes. Yet its early activity suggests a nucleus diameter somewhere between 0.8 to 11 kilometers. What's particularly fascinating is its rotation period of 16.79 hours, determined by the Gran Telescopio Canarias, with brightness variations of only 0.2 magnitudes. This suggests a relatively spherical shape, and unlike typical solar system comets that only become active when approaching the sun, 3I Atlas began showing cometary activity while still 4.5 astronomical units away. That's much farther than normal. Its red spectral characteristics, with a slope of 18 plus or minus 4% per 1,000 angstroms, make it redder than most solar system comets. All these extreme properties mark 3I Atlas as a true alien in our cosmic neighborhood, carrying the unmistakable signature of its interstellar origins and, its billion-year journey through the galaxy. The predecessors. So, how did we go from never seeing interstellar objects to discovering 3 in less than a decade? The story actually begins with one Oumuamua, which made history in October 2017 as the first confirmed interstellar visitor. Discovered by the Pan-STARRS telescope in Hawaii, Oumuamua really baffled scientists with its unusual elongated shape and mysterious acceleration that just couldn't be explained by gravity alone. This cigar-shaped object, measuring roughly 400 meters long, showed no signs of cometary activity despite its strange behavior. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov from Crimea. Unlike its predecessor, Borisov behaved like a typical comet with a visible tail and coma, providing scientists with the first opportunity to study pristine materials from another star system. Borisov moved at 32 kilometers per second and displayed the familiar characteristics of solar system comets, suggesting that similar formation processes occur around other stars. These discoveries really revolutionized our understanding of interstellar space, proving that the void between stars isn't empty but actually filled with wandering objects ejected from distant planetary systems. The rapid succession of discoveries, Oumuamua, then Borisov just 2 years later, and now 3I Atlas in 2025, suggests we've entered a new era of interstellar object detection. Each visitor has provided unique insights. Oumuamua challenged our preconceptions, Borisov confirmed familiar processes, and now 3I Atlas promises to reveal even more secrets about the galaxy's wandering population. The cosmic journey. So, where exactly is 3I Atlas headed, and what can we expect as it travels through our solar system? This interstellar wanderer is currently following a precisely calculated trajectory that will take it on a spectacular tour of our cosmic neighborhood. The comet will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units. That's roughly 203 million kilometers away. Thankfully for Earth, 3I Atlas will never approach closer than 1.8 AU to our planet, ensuring our world remains completely safe from this cosmic visitor. However, the journey gets more interesting when you consider the comet's path relative to other planets. Calculations show that 3I Atlas will pass relatively close to Mars during its solar system traverse, providing an unprecedented opportunity for spacecraft already in the Martian vicinity to observe an interstellar object up close. As the comet approaches the Sun, solar heating will intensify its activity, potentially creating a spectacular tail visible to advanced ground-based telescopes. The James Webb Space Telescope is already preparing observing campaigns to study the comet's composition as it becomes more active. After its solar encounter, 3I Atlas will begin its exit from our solar system, accelerating back toward interstellar space on a trajectory that will carry it away from the Sun forever. This entire journey, from discovery to solar passage to final departure, honestly represents a once-in-a-lifetime opportunity to study an object that has traveled through the galaxy for potentially billions of years. A scientific gold mine. Why are astronomers around the world calling 3I/Atlas the discovery of the century for interstellar research? Well, this cosmic visitor represents an unprecedented scientific opportunity that, combines perfect timing with revolutionary technology. Unlike previous interstellar objects that were discovered too late for comprehensive study, 3I/Atlas was spotted early enough for detailed observations throughout its entire solar system passage. The James Webb Space Telescope, Hubble Space Telescope, and ground-based observatories worldwide are coordinating the most ambitious interstellar object observation campaign in history. Scientists can study the comet's composition, structure, and behavior as solar heating gradually activates its surface, providing insights into materials formed around distant stars billions of years ago. Spectroscopic analysis has already revealed water ice and silicate grains in its coma, but researchers expect to discover much more as the comet approaches the Sun. The object's red spectral characteristics suggest surface materials that have been altered by cosmic radiation over eons of interstellar travel. Advanced computer modeling can determine the comet's likely origin point in the galaxy, potentially identifying the star system from which it was ejected. This research extends far beyond simple curiosity. Studying interstellar objects helps scientists understand planetary formation processes throughout the galaxy, the frequency of planetary system disruption, and the chemical evolution of interstellar space. 3I/Atlas essentially serves as a traveling laboratory, bringing samples from distant cosmic environments directly to our solar system for analysis with our most sophisticated instruments. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to puzzle the world's leading astronomers? Despite intensive study, this interstellar visitor guards many of its secrets jealously, presenting challenges that push the boundaries of current scientific understanding. One of the most perplexing questions involves its exact size and internal structure. While estimates suggest a nucleus diameter between 0.8 to 11 kilometers, the active coma makes precise measurements extremely difficult, as distinguishing the solid nucleus from surrounding gas and dust requires sophisticated techniques. Its unusual red coloration raises questions about surface composition and the effects of billions of years of cosmic radiation exposure during its interstellar journey. Scientists are particularly puzzled by the comet's early activity at 4.5 astronomical units from the Sun, much farther than typical solar system comets begin showing signs of sublimation. This suggests either highly volatile surface materials or unusual internal heating mechanisms that remain unexplained. The object's rotation period of 16.79 hours with minimal brightness variations hints at a nearly spherical shape, but how this relates to its formation and evolutionary history remains unclear. Perhaps most intriguingly, determining its precise origin point in the galaxy requires complex calculations involving galactic motion over potentially billions of years. Researchers are also grappling with understanding how 3I/Atlas maintained its structural integrity during its epic journey through interstellar space, surviving impacts from cosmic dust and radiation that should have gradually eroded its surface over geological timescales. The alien question. Could 3I/Atlas represent evidence of artificial construction rather than natural formation? This controversial question has sparked intense debate within the astronomical community, particularly given the mysterious behavior of previous interstellar visitors. Professor Avi Loeb from Harvard University, who previously suggested that one Oumuamua might be an alien probe, has expressed interest in the unusual characteristics of 3I/Atlas. Loeb points to the object's extreme velocity, early cometary activity, and red spectral signature as potentially anomalous features that warrant careful investigation. However, the vast majority of scientists favor natural explanations for 3I/Atlas's properties. Unlike Oumuamua, which showed no cometary features despite mysterious acceleration, 3I/Atlas behaves much more like 2I Borisov, displaying typical comet characteristics including a visible coma and tail. Its composition of water ice and silicate minerals matches what we'd expect from naturally formed comets in other star systems. The object's rotation period and brightness variations are consistent with a natural body shaped by billions of years of gravitational and thermal forces. Leading planetary scientists argue that the extreme properties of 3I/Atlas Its high velocity and early activity can be explained by its formation in the outer regions of a distant planetary system and subsequent ejection through gravitational interactions with massive planets or stellar companions. While the possibility of artificial origins cannot be completely dismissed without comprehensive analysis, current evidence strongly supports 3I Atlas being a natural interstellar comet rather than technology from an advanced civilization. Dawn of a new era. How has 3I Atlas ushered in a revolutionary new chapter in astronomy and interstellar exploration? This discovery represents far more than just another cosmic visitor. It marks humanity's transition into an era where interstellar objects become regular subjects of scientific study, rather than once-in-a-lifetime anomalies. The Atlas Survey Network, with its 4 50-centimeter telescopes strategically positioned around the globe, has demonstrated that we now possess the technological capability to routinely detect these elusive visitors. Advanced sky surveys like Pan-STARRS, Catalina Sky Survey, and the upcoming Vera Rubin Observatory will dramatically increase our detection rates, potentially spotting several interstellar objects per year. This technological revolution extends beyond simple detection. Modern spectrometers, adaptive optic systems, and space-based telescopes allow unprecedented detailed study of these cosmic messengers. The coordination between 31 different observatories to track 3I Atlas showcases how global astronomical networks can mobilize to study rare phenomena. Future missions may even attempt to intercept interstellar objects with spacecraft, as proposed by the European Space Agency for rapid response interstellar visitor encounters. The implications extend to planetary defense, astrobiology, and our understanding of galactic evolution. 3I Atlas proves that we're entering an age where the study of other star systems will be revolutionized by analyzing actual samples delivered directly to our solar system, making every interstellar visitor a potential key to unlocking cosmic mysteries that have puzzled humanity for millennia. As 3I Atlas continues its ancient journey toward the sun, it carries with it the promise of revolutionary discoveries about our galaxy and our place within it. This remarkable visitor from interstellar space reminds us that we're part of a dynamic, interconnected cosmic community where worlds wander between the stars. For more incredible space discoveries that challenge everything we thought we knew, make sure to like, share, and subscribe to Space Facts, where the universe reveals its most astounding secrets.